Hello everyone. I haven't recorded a video in a long time, and today I want to record an instruction on how you can reduce operations in processing. Let's imagine a situation. We have a certain structure with a link type, and we in this structure have added a new field. We need to write some value in this field. A rather simple scenario, we write the value in one step. In my case, the field was written. Okay, we run our objects, get the result, and so on. 5 objects, 5 operations. We ran 200 objects, 200 operations. It doesn't seem that complicated, but if we have a large structure with several thousand, well, we think, okay, it's not scary. The scenario took only half a minute. We can live with it. Fields are not added every day, and it's not critical. Let's now consider another case. There is, after some time, a new field appeared, and now we need to add this field to each object. Depending on some other field, let's say in my case the same bool, if it is equal to true, then accordingly we assign to my field the value red. Okay. If not, then accordingly, well, it also seems like a simple scenario. Quickly collect, run all our objects. If there are few objects, 100, 200, then nothing terrible. If already 1000, then, well, we think, okay, it's not scary. We can do it once, it's not critical, not on resources, not on the wallet. Let's move on. But these operations arise for us every day, and let's consider such an example. We have a scenario that works on a completely different structure. It doesn't matter. It has some kind of search cube. In this step, we collect an array of links, and all these links are sent to another scenario for editing. Let's say we got 10 objects. Another scenario, there are 3 steps. We got 30 operations. So every day or several times a day or several times an hour. And we start thinking about how we can optimize all this, if there is a simpler and faster way to do all this while spending fewer resources. And before showing how to put it all together, I want to demonstrate real numbers from my project in my application. Let's see. As you can see, on August 7th, I spent 59,000 operations in one day after optimization. Already 14,000. That is, roughly speaking. I save 45,000 operations every day, which is not bad. In my opinion, in principle, you can tweak something else to optimize, but that's another conversation. Let's try to make changes to objects in a slightly different logic. But before moving on to the scenarios themselves, I want to talk about our structures. So we have a link structure. In this structure, there are 2 fields, a bool of type bool and a string type. Okay, there is another structure. In this structure, we have an array of links, here it is, and there is a field of type JSON that will help us change all our fields. Let's delete the data here for the purity of the experiment and move on to our scenario. Let's see how it works. What does the first step, the search step, consist of? In this step, we save the objects in the field of saved links. We can set conditions. In my case, it's just not empty. That is, this object exists. In this step, I form a JSON on top. I assign that we have an object. This object contains an array of objects. And the last line, I just close the array that I opened here and close the JSON itself. Let's figure it out a little later after the run. And the last one we have in this branch is the JSON step. Here we make our schema. There we have links. So here we also add links. If there was at the very beginning of the first line, then here we would have to change the name. Okay, we do the parsing. We take the data from our JSON field and take the data from our links field, the data, the colors, and so on. What we need is we write all this to an array of links where we add the item ID from the color. I think it's all clear. Let's try to run our main object to see how our link structure objects will change. We do this through debug. We send and look. As you can see, all the values for us have become true. Okay, let's change it here to false and see what happens. All values are false. Great. Let's figure out how my JSON is structured. The first line for us is just a string. Then I add another line. But this is not a simple string. Here I use a template, and from each object I extract the ID. If we take it, we'll see that it's in double quotes, and I manually assign some value. After all this, I go to the slice. The slice helps to delete objects from arrays or from a string. If L1 is set, then for a string it will delete the last character, that is, this comma, so that our JSON is valid. As we can see, there is no comma here. If we delete the slice, then a comma appears here. Okay, we've figured this out. That is, we can easily massively assign some values in 3 steps instead of 500 steps. Everything is good, it all works. Let's now see how to proceed if we need to change the value depending on yes, change the value in one field depending on another field. Again, here is a simple search cube, but we will form it in 2 steps. Let's see how it's arranged. At the start, I form a JSON. Oh yes, I form a JSON in the form of a simple enumeration of objects separated by commas. Let's see what we have here. As you can see, we have false everywhere. If we go here and add some value to any object, then for the 10th object, we get true. Because here I added the value and the object itself, if you remove the smart one, then we see that it stands in the template. Further, this whole JSON construction we send to the next step. Edit. Here at the top, there is the same links construction, and at the bottom we also close. But in the middle, we have a radius. The radius is generally a function of the reduce. I use reduce to make it more understandable. You can go to the documentation and see how reduce is all described. I'll try to explain it in my own words. This function always takes the first value as an array. That is, what I formed before. The second is the function. And in this function, we have some kind of accumulator that collects all the values we make. And there is some object that we work with. Okay, let's see how we will work. Let's go back a step. Let's go back. That is, we work with this equal to the first step, and this is equal to the next object, and so on. What we do is for each of these objects, we check the value of the bool. If it is true, then we add this string to the accumulator, the item ID, because we recorded the ID earlier, and add the color at the end, put a comma so that our JSON is valid. Otherwise, we add the green color. After all this, we slice off this extra comma of the last object, and after all this, we also pass everything, and here we save the ID and color. Let's see what we have. We have only 10 values set. Let's run it, update. And as we can see, the color is set only for one object. For all the others, what else can be collected using such a construction? And how can objects be changed massively? The same search. Object. And here in this object, we also do a reduce, but in the reduce, we use the main field directly. Just an enumeration of these objects that were found in the previous search step. What we do is we check the item. If it is divisible by 2 without a remainder, then we accordingly set the bool to false. If it doesn't divide, then we assign and also return. That is, we will get something like an alternation. And let's see how it all goes for us. We run our object and check. As we can see, if we have 10, it's false. If 9, well, and such a ladder. Let's now also send it here, update. And as we can see here too, depending on our field, the bool, the color value has also changed. In this way, you can change many objects in just 3 or 4 steps. Technically nothing limits use, and we can add a color value here, or we can do more complex checks here. The main thing is that it all collects a valid JSON. In this way, spending 3 or 4 operations, we can significantly save our resources. For our application, I would also like to say that this scheme is quite interesting and working for highly loaded applications. And if there are adequate comments, then in the future any person can change everything, fix and understand what is happening. For some small applications, I think this approach is overkill. If you have any questions, ask, or you can write in our TG chat. There I think people will always help and advise. Bye, everyone.